Alright, so today we're going to try to understand the Pythagoras theorem or the Pythagoras rule. Simple, the Pythagoras rule is just a way of comparing the size of a right angle triangle. So when we talk about the Pythagoras rule, we're not just talking about any type of triangle, we're talking about a right angle triangle. That's a triangle in which one of its angle is 90 degrees. In this case, you see that's the 90 degree there. So anytime you have a right angle triangle, then we can begin to think about the Pythagoras theorem. So before we derive the Pythagoras rule and try to understand what it's saying, let's first of all identify the sides of a right angle triangle. A right angle triangle is a special type of triangle, so there are names that are attached to every side. So every side has a name that it bears. So the first thing I want you to understand is I want you to note where, or rather note the side that is facing, the side that is opposite this right angle. So this side that is opposite the right angle is always called the hypotenuse. Alright, and is always the biggest side. So the hypotenuse is that side that is facing or opposite the right angle. Whereas we're going to put forth an angle here. So let's say that this angle, let's say we call this angle B. So now this side that is facing that angle B, alright, the side that's opposite the angle B, well, we just call it opposite also. So this is the opposite side. Then the other side is just the adjacent side. So this will be the adjacent side. But it's very important to note how to clearly distinguish these sides. Alright, so there's none of the side is fixed. So the opposite side is always named the opposite relative to the angle. So let me just explain what I mean using the next right angle triangle we have there. So let me say that we are now comparing, or rather we are considering this angle now. Let me call this angle C. So again, let's try to identify the sides. You see that this side that is facing the right angle is also the hypotenuse, which is the longest side of a right angle triangle. Now the opposite is no longer this side that was the opposite in the previous case. The opposite is always the side that's facing the angle under consideration. So you see that angle C, the side opposite it is called the opposite. So you see that the opposite can switch sides, while the other one will be the adjacent side. So this will be the adjacent side. Alright, so it's very important to take note of these things. Now finally, you see the last right angle triangle we have there. There is a temptation to always think that the slant or the slopey sides are or is the hypotenuse. No, you just need to take note of the fact that the hypotenuse is that side that is facing the right angle. So in this case, this will be the hypotenuse. And especially these things are not drawn to scale, so they always set the questions in this way to try to just to get the question a little bit more difficult and tricky. So you need to be familiar with the size. Okay, I didn't put my side there. Let me say this is my angle D now. So this side that is facing it is going to be the opposite, while the other side is what? The adjacent. So you see, that will be the adjacent. So these are the three sides of a right angle triangle. So back to the Pythagoras theorem. The Pythagoras theorem is just a way of trying to compare these sides. Alright, we're just trying to compare the sides. So how do we do that? Okay, now to understand or to derive the Pythagoras theorem, what we're going to do is, okay, let me just get rid of all these things here so I can use this triangle. Okay, so let's make use of this triangle now. Let's say that the size or the magnitude of this hypotenuse, let's say is 5 units. I'm just using units. It might be centimeter, it might be meter, whichever units, but let's just say 5 units. And let's say that the magnitude of the opposite side is 4 units and the magnitude of the adjacent side is 3 units. Now how do we compare this size? How do we know? Alright, how do you know how do you draw a relationship between the sides? That's what Pythagoras, who is a mathematician, was just trying to figure out. So how to do that? We're going to draw squares. We're going to put squares on each of the sides of this right angle triangle that has the same units, with the length of each side. What do I mean? So for these 5 units, we're going to put a 5 by 5 unit square. For the 3 units, which is the adjacent side, we're going to put 3 by 3 square, and then the opposite side, so we're going to put 4 by 4 square. So something like this. So this is what we have here. Alright, so you see for this adjacent, it's still going to maintain 3 by 3 units. For the hypotenuse, it's still going to be 5 by 5 units. And then for the opposite side, alright, so I always have to put my angle there. So it's still going to be 4 by 4 units. So let's get the area of this square. The area of this square is going to be 4 times 4, right? So we have our 16 units squared, right? So that's the area of this square for the opposite side. This hypotenuse, the area is going to be 5 times 5. So we have 5 times 5. So you see that the area is going to be 25 units. While for the adjacent side, we have 3 times 3. So the area is going to be 9 units. So now, let's compare these squares. You discover that the square on the hypotenuse side is equal to the sum of the squares of the other two sides, because you see that the square of the hypotenuse side, which is 25, is equal to the sum of squares, that's 16 plus 3. So we are coming from this point. Remember, to square this, you did 5 squared is equal to 4 squared plus what? 3 squared. So 5 squared is obviously 25, which we have here. 4 squared is 16, which we have here. And 3 squared is 9, which we have here. So you see that 25 is equal to what? 16 plus, sorry, that 3 there is 9. 3 times 3 is 9, so not 3. So I have my 9. 16 plus 9 is what? 25. So I'm saying that the square of the longest side is equal to the sum of the squares of the other side. So that's the Pythagoras rule. So the Pythagoras theorem, what the Pythagoras theorem states is simple. That the hypotenuse squared, remember this hypotenuse is still 5 units for this our example. So what he's saying is that the hypotenuse squared is going to be equal to the sum of the squares of the other side. So that's the opposite squared plus the adjacent squared. So that's right there is the Pythagoras theorem. So that's what he's saying. Now, if you've understood this, now there's something we call the Pythagorean triples. The Pythagorean triples. What are the Pythagorean triples? The Pythagorean triples are just sets of numbers that obey, all right, that obey the Pythagoras theorem. So you see in this case, this is our example. We have 5 units on the hypotenuse side, 4 units on the opposite side, and 3 units on the adjacent side. So since 3, so right there, since 3, 4, and 5 obey this Pythagoras theorem, meaning the longest side, which is 5, the square of it is equal to the sum of squares of the other side. They are called the Pythagorean triples. So that's what Pythagorean triple is. So 3 set of numbers that obey the Pythagoras theorem are called the Pythagorean triples. Right, so there's some Pythagorean triples you need to know, and also the multiples of these Pythagorean triples are also applicable. So I'll just give you some of them. We have 3, 4, 5. We have 5, 12, and 13. You have 8, 15, and 17. You have 7, 24, 25. So these are the most common Pythagorean triples. Alright, so in each of these numbers I've listed, the sum of the biggest number, which is the hypotenuse, in this second one, the sum, 13 raised to power 2, that means the square of 13 raised to power 2 will be equal to the square of 5 plus the square of 12. So let's just do that. 13 squared is equal to 12 squared plus 5 squared. So sometimes they're going to give you a number, 3 sets of numbers, say, are these 3 sets of numbers confirm if they are Pythagorean triples or not? So what you're going to do, you're just going to use from the Pythagoras theorem. They are Pythagorean triples if the longest side, which is 13 squared, is equal to the sum of squares of the other side. So let's do that. 13 times 13 is 169. 12 times 12 is 144. 5 times 5 is 25. So obviously you see that 169 is equal to 144 plus 25 is 169. That's why we are saying that 5, 12, and 13 are Pythagorean triples. And then remember, the Pythagoras theorem is the hypotenuse squared is equal to the opposite squared plus the adjacent squared. So in the next video, we're going to use our knowledge of the Pythagoras theorem to solve questions. So if you found this video interesting, and educative. Don't forget to subscribe, share with your friends, and click the notification bell so you'll be notified when I post the next video. And don't stop